Oscilloscope is a data acquisition function in eTuner software that mimic a real oscilloscope. It has an intuitive graphical interface and triggering system, which can depict the instantaneous changes of the measured signals. It is a convenient tool for observing the changes of various electrical signals in real time. By adding different observation sources, the changes of electrical signals can be observed in real time, and feedback collected from various signals of the EROB will be displayed as curves. The sampling frequency is up to 20 kHz, which allows for quick and easy capture of hard-to-detect abnormal signals and error information, improving the efficiency and accuracy of the debugging process. The oscilloscope also allows for customizable trigger sources and conditions, greatly aiding the troubleshooting process. The function of the oscilloscope will be demonstrated by triggering a bus undervoltage error alarm as an example. First, connect an EROB to the eTuner, then open the safe power interface. The minimum bus voltage is set to 44,000 mV and the maximum bus voltage is set to 55,000 mV. Then, open the monitor to check that the bus voltage is about 48 volts, which is consistent with the voltage supplied to the EROB. Next, open the oscilloscope interface. Set the data source, choose voltage bus voltage. Click the record variable button to add bus voltage to the list down below. Similarly, add position, actual position, speed, actual speed, current, target current. Then in the signal interface, choose control system error code. Select not equal to as the trigger condition. Set the trigger position to 50%. Input 0 as the trigger value. Set the sampling interval to 1 milliseconds and the sampling duration to 2 seconds. Then click the start sampling button and the data collection progress bar should be in waiting for trigger state. Next, open the motion interface. Click the enable button and select jog forward. The status in the status monitor interface should read enabled, and the current speed is around 131,072. The oscilloscope data collection was not triggered because the voltage is 48 volts, which is within the set bus voltage range. No error occurred, hence the trigger was not met. Next, lower the power supply voltage output to 43 volts. The EROB stops, and the status monitor interface shows a bus voltage undervoltage error, with the bus voltage reading around 43 volts. Simultaneously, the oscilloscope interface data collection progress bar displays data acquisition. Because the current voltage is 43 volts, which is below the minimum bus voltage of 44 volts, therefore an error occurs, meeting the trigger condition. Wait for the data collection to complete, and the oscilloscope chart is at 1 channel currently. You can use the mouse wheel to control the zoom of the chart, or you can zoom into a specific area by holding down the left mouse button and drag to select the area in the waveform chart, then release. To restore the waveform area to its initial state, right-clicking within the waveform area and select Reset. To observe the trends in the data from 4 observation sources more clearly, switch the chart to 4 channels. The bus voltage gradually drops from 48 volts to 43 volts before the trigger position, and stabilizes at 43 volts after the trigger position. Simultaneously, the actual position gradually increases before the trigger position and remains unchanged after the trigger position. The actual speed remains constant before the trigger position, then gradually decelerates to 0 after the trigger position. The target current is approximately 1.6 amperes before the trigger position and shuts off to 0 after the trigger position. The built-in oscilloscope also supports waveform, data saving and loading functions. Click on Save Record. Name it bus voltage undervoltage, then click Save. Close the oscilloscope interface and reopen it. Click on Load Record, select the previously saved curve data, and click Open. You can then load past curve data. This concludes the demonstration of the oscilloscope data collection method by triggering a bus voltage undervoltage alarm.